In the boxes on page 33 and 34, we are going to draw several different kinds of lipids. In the top left, we've drawn a glycerol, and then we've drawn it using organic chemistry format. During 3 dehydration reactions, the glycerol binds to 3 fatty acids, forming a triglycerol. Here we have a glycerol with 3 hydroxyl groups and 3 fatty acids. Each carboxylic acid gives a proton, and the glycerol gives a hydroxyl group, causing a dehydration reaction and the forming of an ester linkage. The water, then, is in solution. This reaction happens 3 more times, and we form a triglyceride and 3 water molecules. In box 1B, we will draw the saturated fatty acid stearic acid. Saturated means all the carbons are saturated completely with hydrogens, or, more appropriately, there are no double bonds between carbons. Next, we draw the unsaturated fatty acid, oleic acid. Notice that there is a cis double bond in oleic acid between carbons 9 and 10. Our final drawing shows a common membrane lipid. This is a lipid that is found in the membrane bilayer. It is a glycerophospholipid. There is a choline, a phosphate, and a glycerol at the polar head of the molecule, and then long hydrocarbon acyl chains as the tails of the molecule. The head is hydrophilic, which is the same as polar and so loves water, while the tails, hydrophobic, hate water and are nonpolar. A molecule with polar and nonpolar parts is called amphipathic. The lipid bilayer is composed of amphipathic molecules. Recall that all life is bathed in water. These amphipathic phospholipids line up spontaneously in aqueous solution. Their non-polar sides, or hydrophobic sides, hate water, so they run away from the water and face each other. They end up in a sphere with their water-loving heads facing the water to the outside and the inside. Below, we've drawn a cross-section of a cell's lipid bilayer, but this animation you've seen shows the formation of a lipid bilayer in cross-section. The drawing on page 34 below shows proteins that associate with the bilayer. Because of the long sections of hydrophobic acyl chain regions on the inside of a lipid bilayer, nothing large and nothing charged can enter the cell without protein help. The polarity of amino acids that make up the membrane proteins determine how these proteins are shaped, and we can also predict where specific amino acids will lie in a protein based on their polarity.